Good morning. You're welcome to our today's class. Today we'll take a look at physics. We'll do physics today. Physics. The topic is motion. Motion. You've heard of the term motion, right?
Yes.
So, from a secondary school, knowledge of physics, tell me what you understand by the term motion. Movement of something. Motion is movement of something. Is that all you have to say about motion? Yeah? Is that all you have to say about motion? Yeah? Yeah? That's all. Alright, okay, let's look at it. So, motion. Take down something. Let's move. Topic is motion. Motion is the change in position of an object with respect to time. Motion is the change in position of an object with respect to time. From here now, look up. I may change my position from here to here. With respect to the time it took me to get to this place. What happened is what is called what? Motion. I said that motion is the change in position, change in position of an object with respect to time. Motion is the change in position of an object with respect to time. Is that clear? Good. So motion is a very important concept. It's a very important concept. In fact, it's a very fundamental concept, not just important. It's a fundamental concept. It's a fundamental concept in physics. It's a fundamental concept in physics that describes the movement of objects from one place to another. It's a fundamental concept in physics that describes the movement of an object from one place to another. Is that clear? Okay. So whenever we are describing the motion of an object, there are some key factors that we should put into consideration. So you can write as a subheading, key factors in the description of a motion. Key factors in the description of motion of an object. Key factors in the description of motion of an object. So motion can be described. Motion can be described in terms of the following key factors. So what it is that this subject is telling that talks about the key factors in the description of motion of an object. What it is that you can never describe correctly the motion of an object without mentioning these factors. Is that clear? Is that clear? Yeah, because these factors affect the motion of an object. So you can never talk of motion of an object without making reference to these factors I want to call out now. The first one is the displacement. Just write displacement, then underline it, put colon. You can write number one, displacement, underline it, put colon. I'll just mention them just at a passing, but we will still describe them when we go to linear motion. Okay, we'll go to collinear motion with the states. We still they describe them, but this is just to mention them as factors that you must put into consideration when they describing motion of an object. One is the displacement. So displacement, this is the change in position of an object. This is the change in position of an object from its initial to its final position. This is the change in the position of an object from its initial to its final position. It sounds like the feature of motion, right? But there's no time there. Did you see any time there? So that is where the issue comes. There's no time there. So take note of that. Motion talks about change in position with respect to what? Time. But this one just the change in position from its initial to what? Final position. Then the second one is distance. Second one is distance. This is the total length. This is the total length of the path. See the spelling of path here. P-A-T-H. This is the total length of the path traveled by an object. Distance is the total length of the path traveled by an object. Look up. If an object starts from here and travel to this place, distance is this length. You measure this length. That's the word distance. If it travel in a circular form, distance is you measure the perimeter, the circumference. Sorry, is that clear? That is what the distance travel. If the object travel like this, the distance is measured all this thing like that. Whatever length it gives you, that's the person's what distance. Is that clear? All right. But displacement is not like that. Displacement, let's assume somebody moves like this. Distance is from here, measuring everything like that. But the displacement is not like that. In displacement you measure the shortest route. So that will get to that particular position. This is the person started from here and found himself here. This is position A and this is position B. But distance is that you go and start measuring all the paths the person take. This is the path the person took. That distance. But displacement, you don't measure the path. You measure the shortest route. Shortest route from A to B is straight to this place. So this length gives what? Displacement. But this one gives what? Distance. Displacement and distance, they are talking about the same thing, but the difference is that displacement has a direction. It's a vector quantity. You know what a vector quantity is now? A vector quantity has magnitude and what? Direction. But a scalar quantity has no direction. So distance is just a scalar what? Quantity. Displacement is a vector what? Quantity. Alright, the next one is velocity. The next factor you should consider is what? Velocity. Velocity. This is the rate of change of distance. Sorry. The first is speed. Leave right speed, please. Not velocity, right speed. Speed. This is the rate of change of distance with respect to time. This is the rate of change of distance with respect to time. Is that clear? So that means distance over what? Time. Is it clear? Yes. We'll still discuss it in detail. It's a scalar quantity. Now, velocity. This is the rate of change of displacement with time. Velocity is the rate of change of displacement with time. Rate of change of displacement with what? Time. That's what? Velocity. Is that clear? Have you noticed something? Speed is rate of change of distance with time. Velocity is rate of change of displacement with time. So that means speed and velocity are just the same thing, but the difference is that speed is a scalar quantity, while displacement is a what? Vector. While velocity is a what? Vector quantity. Because velocity is derived from displacement and time. Is that clear? Is that clear? Are you sure? Don't worry, we will still discuss it in detail. Sure? Next one is acceleration. 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 Okay, this rate change of velocity with respect to time. Rate of change of velocity with respect to time. Rate of change of velocity with respect to what? Time. Rate of change of what? Velocity with respect to what? With time. Change just one. All right. Now discuss this in detail. What are you doing? So the rate of your velocity what? Respect what? Time. Now acceleration is a vector quantity. Acceleration is a vector quantity. Now let's go to the next subtopic: types of motion. Types of motion. Parts that determine motion, then types of what? Motion. Let's look at types of motion. All right, so well, let's continue. There are several types of motion. There are several types of motion. Full stop. They are as follows. The first one, let's look at the first one. Let's start with random motion. Random motion. Random motion. Random motion. Are you there?
Yes.
Random motion. I put down. This is the irregular movement of particles. This is the irregular movement of particles in a fluid. In a fluid, you open a bracket and write liquid or gas and close the brackets. This is the motion of, this is the irregular movement of particles in a fluid. Open a bracket, write liquid or gas, then close the brackets, then continue. Due to collisions with surrounding particles. Due to collisions with what? Surrounding particles. Examples of random motions are as follows. Examples of random motion are as follows. Or simply that examples of random motions are the first one is right, dust particles suspended in the air. Dust particles suspended in the air. Dust particles suspended in the air. The second one, another example, pollen grains floating in water. Pollen grains. Pollen grains floating in water. Gas molecules moving in a container. Gas molecules moving in a container. Gas molecules moving in a container. Bubbles, bubbles, B-U-B-B-L-E-S, bubbles rising in a carbonated drink. Bubbles rising in a carbonated drink. Bubbles rising in a carbonated drink. Smoke particles. Next one. Smoke particles. Smoke particles dispersing in the air. Smoke particles dispersing in the air. Now look up. From the vision, random motion is just motion in an irregular direction. Just no particular direction. Have you ever seen? If you in the night or even in a dark place, put your torch, you see some particles floating in the air. They are moving in no particular direction. That's the example of what? Random motion. They have no particular direction. They move anyhow. Haphazard nature. Haphazard movements. That's what we mean by what? If you take all these examples I give, they are moving in a yes. Is it clear? So that's what we mean by what? Do you know what pollen grain is?
Yes.
What is pollen grain? That's for using what fertilization, right? So if you see it dispersed, it moves in an irregular direction. It's like when it's floating in the water, it moves it cannot move like this straight, no, or like this, no, it moves. Do you know why they move like that? Just like do you know why? You know that this air, let me use particles in the air now, dust particles in the air as an example. If the air is made up of different particle molecules, right? Good. And those molecules are heavier than that of the dust particles. So when the dust particle is suspended in the air, as it's supposed to move like this, had it been is heavier than the molecule of the air, it will just shift them and move, go its way. True of us. Like if you have sand here or people here, right? People here or sand or whatever, or maybe human beings or sand, you can push around and pass. You can pass through and push them. They'll shift for you, you go straight, right? But if you have pillars here that you cannot push, and that's how you rush here. You hit this side and hit this side and hit this side. You start moving like those dust particles because you have they are hitting you from one pillar to post. But because why that dust particles is doing like that, because the molecules is hitting you know that air is gas, you know. So the particle is hitting that dust particle from side, this side to another side, you keep going like that. That's why the movement is like that. The same thing with other things. Even the bubbles and other things, even what is it called? This smoke particles that is dispersing in the air, the same thing happens. Okay? What are you doing? Economics class. Okay. All right, so is it clear? Okay. Now let's go to the next type of motion. Second one is rectilinear. Rectilinear motion. Rectilinear. Rectilinear motion. Rectilinear motion. All right, continue. This is a motion in a straight line. This is a motion in a straight line. Here, comma. Full stop after that. Yes, that here should start with capital letter. Here, comma. The object moves in a single direction. In a single direction. Single. The object moves in a single direction, comma, without changing its direction. We move single direction without changing its direction. Examples of rectilinear motion are as follows. Examples of rectilinear motion are as follows. The fan. Are traveling on a straight road. Car travel on a straight road. A bullet fired from a gun. A bullet fired from a gun. A bullet fired from a gun. A thrown javelin. You know what javelin is? A thrown javelin. A thrown javelin. Next one is a falling object. Falling. A falling object. Example, maybe a ball that is a ball that is dropped from up. You see what I'm saying? Good. The next example is a train moving on a straight track. 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 Is that clear? Now let me explain. From the name, rectilinear means straight. Straight. Yes. The body is moving like this, straight. There's no change direction. No. It's moving straight. If you throw a javelin like this, does it move like this? Does it move like it moves in a straight? Is it clear? It doesn't move like this and come again. No. It moves straight. It's a vehicle that is moving, going from here to this place. Does not start. Target is to get to this place. It moves straight. So any motion that is in a straight line is rectilinear. It's a straight. It's not just a. I hope you know that you can move from here to here without going straight. My target is here. I can go here. Then touch her, how are you doing? And then continue my journey and come here. And I may even come here and come to you and touch you and go out. Did I go from here to here? No, did I go from here to here? I did now. I touched her, don't touch you then. So I actually moved from here to here, three of us. But was it on a straight line? It was on a straight line. Even though I got to this place, but not on a what? Straight line. Am I contemplating? So that's what we mean by what? Rectilinear what? Motion. Let's go to the next one. That one is translational motion. Translational motion. Translational motion. Translational motion. All right, put something down. This is a motion in which an object, this is a motion in which an object moves from one point to another. This is a motion in which an object moves from one place to another without changing its orientation. This is a motion in which an object moves from one place to another without changing its orientation. Is it clear? Now, examples of translational motion are as follows. Are you there? A ball rolling on the ground. A ball rolling on the ground. A ball rolling on the ground. A toy car. A toy car moving across the floor. A toy car moving across the floor. A toy car moving across the floor. A boat sailing across a lake. A boat sailing across a lake. A boat sailing across a lake. Sailing, you know what sailing is, right? A boat, this is a lake. A boat sailing across a lake. A person walking down the street. A person walking down the street. A person walking down the street. A bicycle moving along a road. A bicycle moving along a road. See the spelling of bicycle. See, look up. B-I-C-Y-C-L-E. A bicycle moving along the road. Now let me explain. If you go through what you put down, you think that it looks as if rectilinear motion and translational motion are the same thing. Yes. They sounded as if they are the same thing, but they are not exactly the same thing. There's a slight difference between rectilinear motion and what translational motion. In rectilinear motion, it must be in a single straight, single direction. There's no change of direction for a rectilinear. But a vehicle moving from here to here can come to this place and see a pothole. The driver can negotiate and go like this, two of us, and come back and still get to this place. Is it on a single straight line? But it moved from this point to this point. Even though it changed a bit because of the pothole and get here, it didn't change its orientation. The target is here. It didn't change the target. The target is here. But the difference is that it's not on a straight line. So that means the one that got to this place without moving exactly on a straight line from here to here is translational motion. But sometimes it can be linear. When it gets here from here, straight. Draw a ruler straight. There's no before you get there. It can become a linear motion. Am I complete? So sometimes most of translational motion, all translational motion, all rectilinear, how do I put it down? I want to draw a single statement. I will explain the two of them. I said that a vehicle moving like this from here to here can undergo rectilinear motion. That's a way you can also undergo what? Translational motion. True or false? But the vehicle, everything is on this straight line. Everything is from here to here. So what it is that if sometimes a linear motion, that something a vehicle move from here to here is translational, it may not be linear. It may not be what, even though it is translational, it may not be what, linear. And sometimes it can be translational at the same time, linear. So what it is that in every translational, in every rectilinear, there's an element of what? Translational motion. But not all translational motion are what? Linear. Not all translational motion are what? Linear. So two of them can be confusing. So you be careful about, because especially in JAM, they will start giving you examples. Be careful. So far there's no change in orientation. No change in orientation is translational. But if there's a change, if there's no change in the direction, just single and without going at this and coming back is what? Linear. Alright, so now let's go to the next one. Rotational motion. Rotational motion. I put something now. This is a motion around a fixed axis. This is a motion around a fixed axis. This is a motion around a fixed axis. Full stop. The object rotates around a central point. The object rotates around a central point, without changing its position. The object rotates around a central point without changing its position. The object rotates around a central point without changing its position. Examples of rotational motion are number one, the first one, a merry-go-round. A merry-go-round. Do you know what merry-go-round is? Have you ever gone to a picnic or outing or park park where you go enjoy yourself, Christmas. I mean, you see that thing that people will sit on it. It will go like this. Some will go like this. Some will go like this. That's a merry-go-round. Am I communicating? It just is one place that it doesn't. The main pole, the main pillar that holding it doesn't move is it will rotating around that particular axis. Is it clear? So that's a merry-go-round. It's a rotational motion. Is it clear? The second one is a rotating wheel. A rotating wheel. You know what wheel is now, right? A rotating wheel is a rotational motion. And I go rotational motion. Okay. The next one, a rotating ceiling fan. That one is common now. It's hanging there. Have you ever seen a ceiling fan that moves around on the ceiling? Moves here, moves here, moves here. If you cut your head off now, two of us, it just fixed in one place. And it's a rotational motion. So a rotating ceiling fan. Alright, so let's go to the next one. So if I'm here now, let's assume I'm here. I am fixed in this position. Look at me. I am fixed in this position. But I'm doing like this. I am rotating. I am what? Rotate. So this is what is called what? Rotational motion. I'm fixed here. I didn't move away from this place. But if I start going like this, is that a rotational motion? It's not. That one is circular motion. I'm undergoing circular motion because I am moving around the circle, around an object. Maybe I put something here and keep that. All this childhood play now. You put something in the middle, or people will sit down and you clapping and you run around them. That one is rotational. Circular motion. Rotational is that you are one place doing like this. Is that clear? So let's look at circular motion. Alright, circular motion. Okay, are you there? This is the motion in a circular path. Circular path. This is a motion in a circular path. This is a motion in a circular path. Are we together? Full stop. Here, comma. Here, comma. The object moves in a continuous curve. The object moves in a continuous curve. Here, comma, the object moves in a continuous curve with the distance from the center remaining constant. With the distance from the center remaining constant. With the distance from the center remaining constant. Examples of circular motion are as follows. Are you there? A car moving around a roundabout. You know what roundabout is, right? The car moving around a roundabout. So when the car is moving around a roundabout is circular like this, right? Look up. Roundabout is circular like this, right? maybe the car want to go to this place, or sometimes the car want to go to this come back here. The car will now travel like this and go. When you get to the roundabout, it move it like it go around this. Two of us and join the road again and continue going back. So this is rotation and circular motion. Is that clear? Good. Another example: a bicycle. A bicycle moving around a circular track. A bicycle moving around a circular track. A bicycle moving around a circular track. Okay. The third one. A satellite orbiting the earth. A satellite orbiting the earth. Orbiting ORB. ORBITING. A satellite orbiting the earth. Are you there? Good. So these are examples of what? Circular motion. These are examples of what? Circular motion in a circular path. And the distance, look up. This distance from here, center to the circumference is always the same thing, constant. It doesn't change. Okay. That's the radius. Hope you know. It doesn't change. Is that clear? Okay. So do you now see the difference between circular motion and rotational motion? They're not the same thing. But if you're not careful, you think they're the same thing. Is that clear? Sometimes a body may be undergoing 2 or 3 types of motion at the same time. The body can be undergoing 2 or 3 types of motion at the same time. Okay, take a look at this. A vehicle moving from here, from this bus stop now to the other bus stop. It's a translational motion. The vehicle is moving like this. It's a translational motion. It may not be the linear because the vehicle can shift and continue. Sure, you know. Now, but the wheel of the tire is undergoing what type of motion? Rotational motion. So there are two motions going on there. The wheel is rotating. The vehicle is moving like this. But this vehicle doesn't shift at all. Move like a toy car that doesn't shift. Is rating what? Exactly. Yeah. Doesn't make sense. The next motion, number 6, orbital motion. Orbital motion. Orbital motion. Orbital motion. This is a motion around a central body. This is a motion around a central body, such as a planet or moon. This is a motion around a central body, such as a planet or moon, full stop. This is a motion around a central body, such as a planet or moon, full stop. The object follows an elliptical or circular path. The object, elliptical, see the spelling of elliptical. elliptical, ellipse, elliptical or circular path. The object follows an elliptical or circular path, comma, with the central body at one of the foci. With the central body at one of the foci. Examples of, here now, look at it. Here you see there's a body. Look up. Unlike a secular motion, even though in orbital motion there's an element of secular motion. Rectilinear can be confusing with translational, because in rectilinear there's some element of translational. Secular can be confusing with what? With rotational. Even orbital can be confusing with what? Secular. In orbital there's some element of what? Secular motion. Okay? Now, but the point I'm trying to make is that in orbital motion there's a central body on its own, and there's other body moving around that central body. Just as you see the planets, a planet moving around the sun. Is that clear? A planet moving around. You have about 9 planets, right? And they are all moving around the sun. Electrons move. By the time we do structure of an atom, electrons moving around the nucleus. That electron cloud, they are in orbitals at different distances from the electron. The same way planets are also at different distances from the sun. Hope you know. Yes, there are different orbitals, different levels. The same way we have the nucleus, we still have different shells. We have electrons here, and they're moving around the world, the nucleus. The same way you have the planets. This is the sun. You have the 9 planets in different distances, orbiting on their own around the world. It's not like just one you alone, or a vehicle moving around just on its own. Here we have a lot of other planets orbiting. We call it orbiting at different energy levels, different levels. The same way electrons are orbiting because there are different energy levels and moving. This shell represent different energy levels. Remember in chemistry, we still do the chemistry anyway. But I believe you did this in your chemistry, right? Is that clear? So that's this. Yes, in orbital motion, there's an element of circular motion there, but not just about one object alone. They are in different orbits, orbiting around that central body. And central body, with respect to atomic structure, is nucleus, true of us. And the central body, with respect to the solar system, is what? The sun, true of us. So examples of orbital motions are are you there? The first one, the earth orbiting the sun. The earth orbiting the sun. The earth orbiting the sun. Number 2, the moon orbiting the earth. The moon orbiting the earth. The next one, a comet, C-O-M-E-T, a comet orbiting the sun. A comet, you know about stars now, right? A comet orbiting the what? The sun. A comet orbiting the sun. Number 4, A satellite orbiting a planet. A satellite, satellite, a satellite orbiting the what? A planet. Another example, a planet orbiting a star. A planet orbiting a star. I'll give you examples of electrons orbiting the nucleus. Remember, I'll give you an example here on the board. The electrons orbiting the what? Nucleus. Yes. Put that one down. Electrons orbiting the nucleus in the atomic structure. So when we are done, we go over to the next motion. Spin motion. Spin. When we are done, the next motion is spin. S-P-I-N. Spin motion. Spin motion. Spin motion. Spin motion. This is a type of rotational motion. This is a type of rotational motion. Where an object rotates around its own axis. This is a type of rotational motion where an object rotates around its own axis. Example. A spinning basketball. A spinning basketball. Spin. S-P-I-N-N-I-N-G. A spinning basketball. A spinning basketball. The next one. A spinning coin. A spinning coin. A spinning coin. Have you ever seen a spinning coin before? Where it on its own axis, do like this on its own axis. That is a type of rotational motion, no? But because this coin is spinning around its own axis, it's called what? A spinning motion. This thing when we are tender, it's small boys that play that play. Unless you have elder brother. Are you the only daughter in your house? Except girls that actually have only maybe they are the only one in their family, and others are boys. When they are small, they only those that play like boys. Did you play like boys with boys when you are tender? There's this thing they use the cover of pen. This cover of pen. Then this battery, they remove something from the head of the battery, one plastic thing, and fix it. It will look like this. They do like this. You know that they do like this. It will start spinning on top of the table. That is spinning motion. Is that clear? All right. So let's go to the next type of motion. I think that is the last type of motion we are going to discuss. Oscillatory motion. Oscillatory motion. Oscillatory motion. Oscillatory motion. Oscillatory motion. I put down. This is a repetitive from repetition. This is a repetitive. This is a repetitive back and forth motion. Back and forth motion. Repetitive back and forth motion. This is a repetitive back and forth motion. Full stop. Here, comma, the object moves between two fixed points. Here, comma, the object moves between two fixed points. Two fixed. Let's assume we have point A, point B. The object moves between these. Look up. Let's assume we have point A and point B. The object moves between these 2 points. Is it clear? Move back and forth, or to and what? Fro, or to and fro, back and forth, or to and fro. Am I complicated? Any motion like that is an oscillatory motion. So I said that the object moves between 2 fixed points with the motion repeating itself over time. With the motion repeating itself over time. Examples of oscillatory motion are a pendulum. You know what a pendulum bob is now, right? Pendulum. Didn't you do physics practical in your SS? Come here. What happened? Ma, answer me. Didn't you do practical physics? So how did you pass physics and work? So then how do you write your work if you not do practical? So someone wrote for you. So you can tell me how you pass it now. Do you understand my question? You know do practical. So how do you now do practical in your you know do simple harmonic motion using simple pendulum. Miracle. There's no way you will do practical without pendulum. It's not possible. Physics is not possible. Let me sincere with ourselves. It's all this thing that please, if you are among those that did that in the day, sense to get their way, open your eyes now and stop. Do you hear me? That is in the past, okay? Now, open your eyes and watch. Study. Because there are some holes you must feel. Not all those things will affect you with time. So please try, now that you have decided to study, please make sure that you try to learn all those things. It will not be your fault. But I know that there's no way, you can say that is the simplest practical things you can ever do. Simple room. That's even SS1 work self. That's the simplest experiment you can do in physics. You tie in a metal stand. You tie a ball on a thread. The metal stand is like this, sun like this. You tie the ball, and if you swing the ball, you put your stop clock or stop clock and time it when you move like this. Go like this and come back. One second. Move like this until you take how many seconds how many times it take for a particular number of seconds, and you start plotting graph. This is.
I know something like because I did science.
SSS. I know what I'm saying now. So what happened? Okay, what then? The point I'm making is that this normal things, even though that did arts, did it in the SS1. Let alone someone that did science throughout this and go to WAEC. Yeah. Please, I don't know. You don't want to tell me exactly what I'm about. Anybody that did not know this thing and pass physics, there was an exam malpractice. That is true. Somebody somewhere wrote the exam or was in hall that writing it and they passed. You can never escape this. Am I lying? Did I lie? Did I lie? Did I lie? Yes or no? It's rare to see where without this. It's rare. Most of the exams comes out. Most of the exams. It's rare to see without this thing. So anybody that don't know anything about this thing, somebody wrote work for the person. It's a fact. I'm not trying to make you feel bad, but it's a reality. But thank God you are here now, so let's learn together, okay? If by God's grace, if we go into that, we will discuss it. But I just know that that movement or that bulb is a small bulb that is metal, is strong.